Event-driven architecture sounds like the future, right? It's scalable, it's decoupled, and also responsive. But what about the parts that they don't tell you about? It is a big architectural decision and engineering commitment. So today, let's dive into the real challenges of event-driven architecture that every developer and architect should know before jumping in. My name is Derick Chen, and this is BuildWithDC. Let's first recap at a high level what event-driven architecture, or EDA, is, and then do a quick comparison with request response alternatives. Both event-driven and request response are integration models for distributed software architecture. In request and response, which is often implemented as REST APIs today, there is a client and there's a server. The client initiates a request via an API call and expects the server to respond with the correct data within a certain time limit. In this method, there is both a step and temporal coupling. On the other hand, in event-driven architecture, services communicate by producing and consuming events in an intermediate queue, instead of calling each other directly. The service that creates the events and puts it into the queue is known as the producer, while the downstream service that monitors the queue and carries out logical processing is known as the consumer. This decouples systems as threads are no longer waiting on the responses and lets them scale independently. This is a commonly encouraged method for distributed architecture in the realm of microservices. But it certainly comes with its own set of challenges and drawbacks. In a pure event-driven architecture, you will have multiple event queues. Different consumers subscribe to various different queues. Basically, events are flying everywhere. When everything works, it's fantastic, because now every service can scale independently of each other and is a great improvement on the performance of the overall system. But when there is a bug, it can feel like finding a needle in a haystack. In a distributed system with loosely coupled integration, and we will come to whether it's actually loosely coupled or not in a short while, but when you have an issue in such a distributed system, I like to say that you will smell the smoke, but you won't necessarily see the fire. With a naive implementation, the events and their associated data are distributed in different services. A user's action on the web page can trigger 5 different events being created and sent to multiple backend services downstream. Good luck debugging that in production. And are event-driven systems truly decoupled? A big selling point of event-driven architecture is that they are supposed to be decoupled, meaning that services should be able to be scaled and deployed more independently. Well, it feels like it. Now that you have services that don't need to wait for immediate responses, they simply fire off the events and then move along with the processing. But your services are still tightly coupled to event formats and consumers. If the producer service needs to update the data structure of the event or the event schema, then now you risk breaking multiple consumers you might not even know that existed. And if there is a production issue because of this, it will be really hard to determine the ownership, which team is responsible, or which service even. With the benefit of no more temporal coupling, it means that the events are no longer guaranteed to be processed immediately. This is known as eventual consistency. Meaning the events will be processed, that's for sure, but it could be 100 milliseconds later or in 100 seconds, and that makes a big difference. And worse, if this transaction depends on other data that might change, you might have a data consistency issue during this period when the event is waiting to be picked up by the consumer. For example, when an online store makes a sale, the billing system processes the payment and emits an event for the inventory service to update the stock as sold. But in a sales event like the Black Friday, this could lead to overselling of inventory that you don't have. The inventory service might be taking longer to finalize the transaction than how quickly the billing system is accepting and processing payments from new customers. This is certainly a case where scalable orchestration with compensation could work way better than an event-driven system. Also, with the complexity that comes with operating EDA systems at scale, with all these moving parts, message brokers, queues and dead letter queues, consumers, producers, subscriptions, Monitoring all of them is not optional. And you need to monitor and log them correctly without making debugging 1,000 times harder. You will need advanced observability and alert tooling for distributed tracing, message replays, and on-call paging. And of course, you need capable DevOps engineers or a platform team that could operate this at scale. And over time, there's no question that your event queues and event schemas will change as your business evolves. And when this event queues or the schema changes, you need to try to maintain backward compatibility. That is painful. Firstly, you have to diligently document and monitor different event versions, as outdated consumers may break the system. And then, as the events are typically emitted asynchronously, you don't actually have a direct and programmatic way of responding to the producers that the expected event structure has been changed. Enforcing the schemas and contracts matter a lot here. Event-driven architecture can be very useful when implemented and operated right. But in order to do that, there is a minimum engineering maturity that is required from the organization. I can almost guarantee you that event-driven architecture will not be 100% of your use cases for service integrations. You still need to analyze the requirements and consider the trade-offs. Event-driven architecture isn't a silver bullet. If your system is simple, strongly consistent, and doesn't need massive scalability, then traditional request response designs might serve you better. EDA unlocks amazing capabilities when used right, but it does come at a cost. And it's so important to know the trade-offs before you dive in. If you like the content, remember to like the video and hit the subscribe button. My name is Derick Chen. Thanks for watching, and I will see you in the next video.